Our senior project is with Slow Brewing Company, which is one of the fastest growing breweries in the San Luis Obispo area. In the last 2 years, Slow Brew opened a new facility called The Rock, which produces on average 1,500 cans per month. With this new location and an increase of production, Slow Brew's distribution radius has also grown. Their cans are shipped all over California, globally to Australia and Puerto Rico, and they will be expanding even further in these coming years. The head brewer, Steve Currier, is concerned that Slow Brew's focus is on volume and meeting customer demand instead of their quality of beer being produced. After also speaking with Brian Kerr, the marketing director of Slow Brew, we discovered he was also concerned about the quality of beer, and that quality of beer is the number one driver for repeat sales. Steve believes that the low quality of beer is due to the introduction of oxygen into the cans of beer during the canning process. He gave our group the project of figuring out why.
Over the course of our project, we have visited Slow Brew about 15 times. Working closely with the canning operator and the brewmaster, we are able to be on the factory floor during canning to learn the process, understand the product requirements, and conduct experiments. We spent several of our first visits taking time to make sure we had a good understanding of how the canning line worked, and even assisted with a few canning runs to build rapport with the team. The team at Slow Brew was very helpful and willing to listen and implement changes as we learned from one another. Consistent data collection was a key component of our project, and the team at Slow Brew was very flexible when it came to assisting us in the execution of our experiments.
Our problem statement is, Slow Brewing Company's canning line currently does not have a robust enough quality control process to ensure their product's quality meets industry standards. Oxygen is being captured in the beer, and these oxygen levels must be lowered for a product flavor to remain consistent throughout the product's shelf life.
To verify this issue, our team examined oxygen content data and found that Slow Brew's average oxygen levels were about twice the levels of the industry standard. As you can see here, there is almost always an increase in oxygen after the canning line. After researching beer canning lines and finding that the increase in oxygen was much higher than most breweries, we were able to focus our efforts on the canning line itself. After researching and meeting with experts in the industry, we were able to design several experiments to test the effects of different factors on oxygen levels. While the experiments we will discuss today were not the only ones we conducted, they proved to be the most relevant to the outcome of our project. The three factors we experimented with were filler volume, filler pressure, and CO2 timing.
Our first experiment was to determine if there is significant variation between the 6 filler heads of Slow Brew's canning line. Different fill heights means different headspace volume in cans, which leaves more oxygen in some cans while less oxygen in others. To quote Bamforth in Brewing Material and Processes, specific fill heads are often problematic, and understanding each filler and creating realistic expectations based on its capability is essential to quality beer. Our team collected samples from each of the 6 filler heads and weighed the cans in order to determine if there were any variations. We then used this data to perform a one-way ANOVA analysis to determine differences between the means. After completing this experiment, we discovered that there was significant variation in the fill heads, primarily fill head number 2 and fill head number 5.
Our goal for the second experiment was to increase the amount of foam on the beer by changing the filler pressure to limit the product's exposure to oxygen. This strategy is referred to as the cap-on-foam technique and is widely used in the industry. We collected samples before and after adjustments, and after analyzing the data using a one-way ANOVA test, we found that although there was a slightly lowered mean, the improvement in oxygen levels was not statistically significant.
For our third experiment, our team adjusted the mechanism that sprays CO2 during filling, with the goal once again being to create more foam on top of the beer. The reasoning behind this experiment was the same as the last one. Our literature explaining capping on foam strategies and limiting the beer's exposure to air. To do this, we collected samples before we made our adjustment and collected samples after, measured the oxygen levels, and then performed a one-way ANOVA test to find the difference between the means. Similar to the last experiment, our sample after we made our adjustments had a slightly lower mean, but the difference was not statistically significant. In summary, our first experiment showed that there is a significant variation in fill heights that is dependent on each filler. The next two experiments that aimed to increase foam and lower oxygen levels did not show a significantly lower mean than our control groups in our ANOVA analysis, but we were able to achieve lower oxygen levels than before. Since these methods have no costs associated with implementation, and more improvements can be seen with continued use, we believe that pursuing them is still worthwhile. Based on the results of our experiments, our team designed several operational changes to mitigate the introduction of oxygen. First and foremost, the team created a new operator's log. This will help the operators record different pressures and other machine set points that may help them identify other sources of oxygen. Now they will be able to use a more methodical approach to isolate these issues. We also suggest that the team continues to increase the amount of foam for cap-on-foam purposes. By adjusting the pressures and other CO2 set points incrementally, they may continue to see more improved results than what we were able to do with our small sample experiments. Slow brew should also prevent future variability in fill heights. Although there aren't many adjustments to be made on the machine itself for this, slow brew can mitigate this effect by monitoring maintenance schedules to ensure that all fill heads have their seals changed and other moving parts lubricated at the same times to help minimize that variability. Also, more equipment should be purchased to more accurately gather data on headspace volume rather than just can weight to more accurately project their oxygen values. A headspace air tester costs $1,500 and will help accurately quantify the headspace volume in a can. A shaker table costs $2,500, and this will assist in testing the levels of oxygen. These testing methods are standard in industry and will help the slow brew team accurately quantify their oxygen levels and understand the variation due to the filler heads.
Since Slow Brew started canning, they've brought in roughly $630,000 a year from selling their cans. Based on our research on flavor degradation and the variability we witnessed in oxygen levels of cans leaving Slow Brew, our team estimates that at least 25 to 35% of cans sold have a flavor not true to brand and are of poor quality. This will cause a drop in customer retention. Although repeat sales are difficult to quantify, we believe that at least $190,000 will be lost in sales annually due to lost customers. With our quality control procedures and small investments in equipment, we believe Slow Brew can lower the percentage of poor quality cans produced to 5 to 15%, which will increase repeat sales and save roughly $125,000 annually.
The changes that we have suggested do have some secondary impacts. An operator has plenty of duties during a normal canning run, and collecting more data will impact the operator's workload, giving them more to do. Also, flavor profiles of the beer should be monitored over time, and a team should be closely following how their product changes as a result of oxygen levels. These kind of tests are typically run by a lab manager at other breweries, and it would be a good idea for Slow Brew to consider investing in personnel that could assist with collecting data, analyzing data, monitoring flavor profiles, and helping out with other general procedures around the brewery. We thank you for taking the time to watch our video, and we look forward to answering your questions when we get to meet face to face.